Hello, and welcome to Learning Enhancement Session 1 for Year 7 to understand the differences between energy stores and energy pathways. Before we get started, can you please make sure you're in a quiet room, you have a piece of paper with you, a pen, a ruler, a green pen or another coloured pen or pencil, and something to write on so we can get started. Can you make sure also you put away any technology, headphones away, and can make sure we're listening and focused for the duration of this video. Okay, so as I already explained, what we're doing in this learning session is to understand the differences between energy stores and energy pathways. A common misconception, going to understand what differences between them. Okay, but before we get started, can you give yourself just 2 minutes to jot down all you can and answer the question, what is energy? So pause the video for 2 minutes, have a go, jot it down now. So your time is finished there. Should have given yourself about 2 minutes just for that. Then you pick up a green pen or another coloured pencil and we'll go for this now. So what is energy? Energy is simply defined as it cannot be created or destroyed. It can be stored or can be transferred, i.e. from a hot object to a cool object by conduction, convection or radiation. The key part here is energy cannot be created or destroyed. This is called conservation of energy and is a key part of GCSE and Key Stage 3 science. So, success criteria for this learning session, just to name the 7 types of energy stores, state the energy store transfers in examples given, and then understand the 3 types of energy pathway, understand they're different from energy stores. So, when we describe how we use energy, we need to tell a story involving how the energy has been stored and the pathway that the energy is taken to shift between different stores. So we're going to learn about the 7 energy stores and the different ones and how energy can be transferred between one and another and the pathway it takes. So there are 7 stores: the chemical, nuclear, which are examples of fuels, kinetic and thermal, which move, and then gravitational, elastic, and electromagnetic, which all have potential energy. So a good way visual representation just to remember this, the 7 energy stores. First one being thermal, which is example of fire, so heat is a key word there. Next one, we've got a bicycle moving here, so that'll be kinetic. Kinetic is just a simple word for, just another word for moving. Next one being nuclear. So nuclear there, such as nuclear bombs, nuclear power stations, nuclear fusion reactions in the sun. Then we have over here on the right hand side, electromagnetic, chemical, such as food, batteries, and fuels such as wood and petrol that burn. We have these parachutists here, so gravitational, and last but not least, the elastic bands that will be elastic. Okay, so those are the 7 energy stores, and these store energy that can be then transferred to another form, but it cannot be created or destroyed. That's a key part. So, just got a quick task for you. Can you pause the video just for 1 minute? Can you write 1, 2, 3, 4, 5 in the margin, and can you tell me which type each one is, which energy store it is? So pause the video, 1 minute, go. Okay, your time is up there. You've had a minute there, so can you pick up green pen or another coloured pen and pencil, and we'll go through this now. So number 1, it's actually in the image, it's quite a bit of a clue there, is elastic. So that'll be elastics. Number 1 is elastic. 2, we have a rock climber there, just parasailing above. That will be gravitational because of the height. 3, because the heat involved is quite hot, that'll be thermal. So number 3 is thermal. 4 is chemical because its batteries contains chemical store of energy, and then 5 will be electromagnetic. 5 there. Okay, give yourself a mark out of 5. If you got 5, excellent. 4, well done. 3, brilliant. 2 and 1 just need to focus on improving on understanding energy stores. Okay. So, second task, and this will take about 4 minutes, guys. 4 minutes. Can you pause a video now? Pause the video and try and connect each energy store to its definition here. Okay, pause the video. You have 4 minutes. Go. Okay, time's up there. Can you pick up a green pen or another colour pen or pencil, and we'll go through this now. So, thermal is when materials warm up, so heat is involved. Kinetic, object speeds up or slows down, so there's motion and movement. Chemical, atoms combine together to make a new product. Nuclear, nuclear fission or fusion, such as in a star or nuclear power plant. Elastic, material, such as an elastic band, is stretched or squeezed or relaxed. Gravitational, massive objects separate or fall together. And electromagnetic, magnets with charged particles alter separation. Okay, give yourself a mark of 7 and we'll move on. Okay, so we've done that. We've named and defined the 7 types of energy stores. Now we're going to state the energy store transfers in examples given. Now we know energy cannot be created or destroyed. That is just the principle of conservation of energy, is a key part of physics. But what we may not understand is that it can be carried along a pathway from one energy store to another. As it's never created or destroyed, it's simply just energy is simply changed from one store to another. So if I have some chemical energy in the form of wood and I burn it, that's going to go from chemical energy in the wood to then thermal, as in the fire, and that will be altered along the pathway of heating. So we've got an example here. First example, as a ball falls to the ground, what is true? The energy stored that decreases will be gravitational, because it starts at a height and then falls down, and then it goes into kinetic because it's moving, but also thermal because it's a bit of wind resistance and friction, force friction. Okay, second example, as a car suddenly stops, what is true? So the energy stored that decreases will be kinetic because it's slowing down, it's stopping to move, slowing down, stopping to move to a station, to a stationary halt. And energy stores that increase will be thermal, as you can see here by the smoke, because heat is generated by the friction of the brakes slowing down. So it's slowing down, kinetic is decreasing as the thermal increases. Okay, as a candle burns, what is true? Can you pause the video just for 10 seconds and have a go yourself? Okay, time is up there. Time is up there. What you should have got is it is chemical because it's in a candle, it's wax, it can be burnt. It's a chemical store as a fuel, and because of the light being produced, it will be thermal, so light and heat. That's the key part there. So chemical is a decrease, and the energy store that goes up will be thermal. Okay, as a hydrogen bomb explodes, what is true? Can you pause the video again for 10 seconds and tell me and write down which energy store will decrease and which energy store will increase? Okay, hopefully you got that is nuclear, because that will decrease and then that will be converted, so nuclear energy store will be converted, changed into thermal by the heat produced by the nuclear bomb, the hydrogen bomb, but also kinetic because as the particles move further and further apart, and see the dust clouds and then mushroom clouds there. Okay, so what we've just done there, we stated the energy store transfers in examples given. You can see how real life examples that we've seen in our everyday lives and beyond show how energy stores can be transferred in simple examples. Okay, and the final thing, guys, the energy pathways. Okay, there are 3 different key parts, 3 different types of energy pathways. This is how it gets transferred from one energy store to another. So if I've got a chemical store that's converted into a thermal store, energy store, there are 3 ways it can take to move that way. The energy can move through it. So first one would be mechanically, objects moving due to force acting on it, which simply means it's simply just the forces of acting on it. So picking stuff up, using a crane, using hands, using movement. This is the key part for movement. Electrically, So a charge moving through potential difference. So electric charge passing through wires to carry chemical energy into the form of thermal. So if you're using a light bulb, it needs batteries in the chemical, go through the wire, electricity goes through the wire to the light, where it turns on the light and heat, which would be thermal. And then the last one, heating, that's going to be done by radiation wise, such as microwaves or infrared, or by particles moving from a hotter to a colder subject, such as convection, such as your heaters, or when you're cooking some pasta by conduction, the hob will heat up the pan and then some water, and that is conduction. So those are the three energy pathways that energy must take to transfer from one store to another. So an energy store is a different type of energy. A energy pathway is how those energy stores change and the pathway it must take. Okay, and that is the final three, understanding the three types of energy pathways. That is the end of this learning session. I hope you understand the difference between energy stores, the 7 types of energy stores, and the energy pathways they must take. Okay, thank you.